There is one question we get a lot from industrial customers: what is the proper wavelength range to sort my samples? There are two ways to find this out. First of all, you could look from a literature, scientific articles or books. But the second, more straightforward way is to just make test measurements. I'm going to demonstrate this using two different kinds of samples. First, fabrics from different colors. There are polyester, cotton, wool. And the second sample type is nuts, and I'm going to demonstrate how to separate the nut meat from the shell. So let's start. To demonstrate if an application can be done with an FX17 wavelength range from 900 to 1700 nanometers, I have measured some samples using our laboratory scanner, known samples which contain wool, polyester and cotton. After that, I import them to a software, and in this case I'm demonstrating using the Perception Studio software from Perception Park company, Austrian company. This is quite intuitive software and it gives good insight how the spectra looks like. First, I select the spectra for each individual material. First, polyester, which I know is here. Then the second spectra, cotton, which I know is here, and last, wool. And we can immediately start looking the spectra and the possible differences. And indeed we have quite distinctive differences in this region and also this region, meaning that this application most probably, or actually in fact, can be done using FX17. We create the application and then we look at the results. So yellow was wool, blue, cotton and green polyester. On the one side of the image we had three fabrics made out of cotton, and they are classified as cotton as the one that I was pointed out, although they had different colors. My second example is of pistachio nuts. We want to sort the nut meat from the shell. I have already imported the image and selected the shell areas and the nut meat, and when we look at the spectra we see that there are a lot of intensity changes and the spectral differences are not that clear. In this case I prefer to use normalization and also first derivative to see the spectral changes. And again we see that at least in 1200 nanometers and even in the longer wavelengths we have clear separation of spectra. And if we make the classification, we see that the result seems to be rather good. We have been able to separate the nut meat from the shells.